Okay, question two. Somebody wants to rent a car, and it depends on what's the most economical car to run in terms, and that essentially boils down to the cost per litre of diesel and petrol. So you're given those kind of current prices. You're told how quickly diesel and petrol the price is increasing per day. These are somewhat apocalyptic percentage increases. But really the purpose of the question is just to get you familiar with using a for loop. So you have to using a while loop. You have to use a while loop here, okay? Because we don't know how many times we are going to loop around. So basically, after day one, the current price of diesel at 189.9. We add 3% onto that. Okay, which is probably about 5 cents or so, roughly. So 195 cents per litre on day two, and so on. And with petrol, we go from almost 180 cents, and that is 5% per day. So that's probably about 8 or 9 cents extra after the first day. And then after 7 days, petrol is going to increase, but at a slower rate. So it's going to increase by 2.5%. Okay, so you can see that petrol is cheaper at the beginning, but for the first 7 days, the price of petrol is increasing at a higher percentage rate than diesel. Okay, so it's possible that after 7 days, petrol would be more expensive than diesel, but then petrol will start to increase at a slower rate, and diesel may overtake it. Okay, so there's a lot going on here day by day. The situation may change. Okay, so John needs to know how long it's going to take basically before the price exceeds 2.50, 2.5 euros per litre. Okay, now you just need to be careful here because the price of diesel and petrol is in cents per litre, but in question A, the price exceeds 2.5 euros per litre. Okay, so you need to standardize all those. You can either make them all euros per litre or make them all cents per litre. Okay, either way is fine. You can see the output there is expecting cents per litre, so it's probably a good idea to have your price exceeding limit as 2.50 cents rather than 2.5 euros. Okay, and then the modification is instead of the 2.50 cents per litre, let the user type that in. Okay, so let's go to our question then. So looking at the question and the required sample output, the question sort of breaks down into the following pseudocode. Okay, we are going to have our variable declarations. We've got certain constants we're going to use, i.e. the price of petrol and diesel at the start, and the rate of increases as well. Okay, they're fixed. The ultimate price of 2.50, that's actually not going to be constant because in part B the user can change the fuel limit. Okay, so we'll sort of factor it in from the start. I think it's straightforward enough to do that. Okay, so we'll declare the variables, get the fuel limit from the user, the upper fuel limit. Okay, and basically we're going to do our calculations. How many days it's going to take will be based on that. Okay, so the repetition then, the loop is going to need to handle the following. Okay, as long as either diesel or petrol cost less than the max. Okay, so because the rates are different and because the starting point are different, one of these fuels could be less than the max, and the other could be greater at the same time. Okay, so we are going to need to check that. Okay, so if either, once we're inside the loop, for each one that's less than the max, we are going to have to increase the price of diesel, okay, or the price of petrol. So the number of days where before we reach the limit, that's going to increase by 1 in both cases. Okay, we're also going to have to multiply the current diesel costs by the particular percentage, which is 3% for diesel, 5% for petrol, And we also need to check if it's more than 7 days, the cost is going to change. The increase is going to slow down to 2.5%. Okay, so as long as one of them is less than the max, one or both, I suppose, yeah, we're going to have to do that process. Okay, eventually at some stage, both diesel and petrol costs will exceed the upper limit that the users typed in, or 250 cents, and then we'll be able to output. Okay, and the output should essentially be what is the cost of petrol or the cost of diesel after so many days, and from that we can make a judgment as to which car engine type is the best value. So what variables are we talking about? Excuse me. Here's our current diesel price, and that's a constant. Current petrol price, that's a constant. And then that price is going to change day by day, so we are going to need a double variable there, not a constant, and a double petrol. So that's basically diesel price, petrol price on a particular day. I have got the 3% increases as final double constants as well. Okay, and I'm also going to have 2 increment counters, the number of days for diesel or petrol inside my while loop, and they are going to increase by 1 each time the price hasn't met the maximum. Okay, in the case of part B, we will be getting the upper fuel limit from the user, so I'm going to need the scanner utility from the library. Okay, and we'll create a scanner object called KB. Okay, part A, I don't need scanner at all. I can just hard code in the starting value, or the value for max is 250, but I do need it for part B. So what happens inside our loop? As long as either diesel or petrol costs less than the maximum, 250 or whatever the user's typed in, okay, so there's my condition. If diesel is less than max or petrol less than max, what I then need to do is basically work out the new value for diesel and petrol and increment the number of diesel and petrol days inside this loop. Okay, you can see all that is happening inside that loop there. Okay, now both are unlikely to exceed the max on the same day. Okay, so at the end, at the very end, we're going to say something like, you can see on the message, you know, petrol will reach, there's over 250 in 7 days. Diesel reaches over 250 for the first time in 10 days. Okay, so the number of days is different. Okay, so sometimes, if you think about that, 3 times around the loop, diesel days will have been incremented 3 times more than for petrol days. Okay, so petrol reaches 250 quicker. Okay, so what does that mean essentially? If the price of petrol was being calculated for 10 days, the price of petrol would be much higher. Okay, it would be 2.5% increased, so that is about 7 cents more, maybe 8 or 9 after. So we're talking about probably 25 or 30 cents more expensive than diesel after 10 days. Okay, so diesel is cheaper over 10 days. Okay, that's why John should go with a diesel car. Okay, so what are we doing here? So is diesel less than the max price? So each time around the loop, it's certainly going to be true the first time. Increase diesel days by 1 and multiply it by the percentage increase. Okay, and so it's going to be diesel equals diesel times 1.03 in this case. Okay, so the price of diesel is getting bigger all the time. Similarly, notice the shape of this. We've got if diesel less than max, increment, multiply. Okay, if petrol less than the max, increment, and then multiply. But we are multiplying 2 different ways depending on if 7 days has passed or not. Okay, so 1.05% up to 7 days, including 7 days, and then 2.5% afterwards. So that's our while loop. At some stage, both prices will go beyond 250 cents per litre. In that case, we will exit the while loop. And then we want to tell the user, basically, petrol will reach. And what will be printed here is the smallest price per diesel, the smallest that is greater than either the 250 cents or the price that is being typed in by the user. Okay, because that's when we stop going into that if statement inside the while loop, and similarly for diesel. Okay, so essentially what we're trying to find out is how many days does it take to reach 250 cents or whatever the user has typed in. Okay, so the more days it takes to reach that price, the better value that particular engine type is going to be. Okay, so if the number of days, basically what does this mean, diesel days, the number of days for diesel to reach the price that has been typed in by the user, or 250 cents, okay, if that number is greater than the number of days it takes for petrol to reach that price, then it takes diesel longer to get to that price. Okay, so diesel is better value. If that's not true, John should go with a petrol car. Now, you could argue, well, I should have an else if here, else if diesel days, what about diesel days equals to petrol days? Now, in this case, that is very unlikely to happen because we're dealing with floating point numbers for the percentage increases. We're dealing with floating point numbers for the petrol prices at the start of 0.9. So it's very unlikely that both prices would be exactly the same. Okay, but arguably you could put in else if diesel days less than petrol days there, else it doesn't matter which one John picks if the prices are the same. Okay, so let's run this. Okay, and if we put in something like a small number, you can see petrol makes more sense. If we put in a larger number like 500 cents per litre, okay, John should go petrol. Petrol makes more sense there because it's more than 7 days. Okay, so the rate of increase is slowing down. But if you are in something like, well, 250, okay, let's put 250 in. You're in that space where diesel makes more sense. Okay, so petrol is cheaper at the start, but the rate of increase is larger. That makes diesel cheaper after so many days, but then petrol becomes cheaper again later on because the rate of increase at 2.5% is smaller than the rate of increase for diesel.